Find the lateral seismic force F3 in kips. In this problem, a 4-story office building is shown, with the height and weight of each floor provided. The building is constructed of a steel moment-resisting frame and a seismic response coefficient of 0.224. The lateral seismic force of a floor equals the vertical distribution factor, CVx, times the seismic base shear, V. We'll first compute the seismic base shear by multiplying the seismic response coefficient, CS, by the effective seismic weight, W. The problem states the seismic response coefficient equals 0.224. The effective seismic weight is defined in section 12.7.2 of ASCE 7 and usually equals the total weight of the structure, unless dealing with live loads, snow loads, or partitions. After plugging in the weights of each story, the effective seismic weight equals 290 kips. This makes the seismic base shear, V, equal to 65 kips. Next, we'll solve for the vertical distribution factor, CVx, which distributes that 65 kips of shear force to each story of the building. Since the problem asks to find F3, we'll substitute in 3 in for subscript x. The vertical distribution factor for a story equals the weight of that story, Wx, times the height of that story, Hx, raised to the period exponent k, all divided by the sum of that same product for all of the stories in the building. As before, we'll substitute in 3 for subscript x to solve for the vertical distribution factor CV3. From the problem statement, the weight, W3, equals 80 kips, and the height, H3, equals 12 feet. And the period exponent, as we'll call it K, depends on the fundamental period of the building, T, which ranges from 1 to 2. The period of the building can be approximated by multiplying CT by Hn raised to the x power, where Ct and x are constant values based on the structure type, and Hn is the height of the building in feet. The total height of the building equals 15 feet plus 12 feet plus 12 feet plus 12 feet, which equals 51 feet. The constant Ct and x are determined using table 12.8-2 in ASCE 7. Since the problem states the office building is constructed with a steel moment resisting frame, the values of Ct and x are 0.028 and 0.80 respectively. This makes the approximate period of the building equal to 0.65 seconds. Using linear interpolation, 0.65 seconds corresponds to a k value of 1.075. Plugging in the values for W3, H3, and K, as well as the weights and heights for all stories in the denominator, the third story vertical distribution factor equals 0.349. And the lateral seismic force, F3, computes to 22.7 kips. When reviewing the possible solutions, the answer is C.